critical signaling pathways. And there's a lot of data now that suggests that all of us that have been taking certain supplements, it may not be the wisest thing. Okay? Okay, so let me just run through really quickly a couple of examples. Okay? So first of all, you can ask yourself, can small molecules, can they cure a complex disease? Or can they really fix a complex problem given this complexity with the modularity that I just mentioned? And here's the survival of kids, mostly kids with ALL. Okay, and you can see 80-90% of these kids are now survivable on drugs, and with bone marrow transplants, it may be 100%. Okay, so the answer, of course, is yes, if you have the right cocktail. Now, the example that I'll focus on is Cardiovascular Reserve. Okay, and so this is probably the most important one to the audience here, and I'll have some things to say about a couple of these processes. Okay, these circuits that we can modulate today. How important these will be for SENS remains to be seen. And of course, we've made some progress with heart transplants and stuff in terms of a modular solution. Okay, so here's a very interesting longevity set of data. You can see that all of these mammals have roughly the same number of total beats in a lifetime. It's roughly 10 to the 9th, plus or minus a few beats, even humans. Okay, so that's kind of interesting. So that brings up the question of universal beta blockers, or something like that to slow the heart rate. Okay, would that reduce the stress on the heart, reduce the stress? And there is some evidence that this might be an interesting idea. Okay, and here you can see folks with higher heart rates up here, lower heart rates, and the death rates here or over here with heart rate. Okay, another set of interventions I'll just have a couple of words about is what I call something sweet, salty, and fatty. I was assuming when I put this talk together that there would be more of this pathway talked about because of the recent press on resveratrol and on rapamycin.
There was supposed to be a talk on it, but the guy, it was got sick.
He didn't show up, yeah. So I'm not really going to have anything more to say about that, except that we know that this is an incredibly important pathway, and that a number of the genes and interventions that appear to extend the life, not SENS, but extend the lifespan of a number of model organisms act in this pathway. Okay? So one of the drugs that's very interesting is metformin, a licensed drug. It's not very toxic. You can use it today. Resveratrol, I know a lot of people are taking that, but the jury's probably out on that. I'd be interested if the audience had any questions or comments about that. It acts in a couple of doses. Okay? One of the most important pathways is the RAS, the renin-angiotensin system. And I don't have time to go into this in too much detail, but it's a set of proenzymes that get converted by enzymes into angiotensin II. Okay? And this is a good thing to have happen in our ancestors that would bleed to death or did not have sufficient supply of fluids. But under a Western diet, this ends up causing serious cardiac and vascular problems, hypertension, and a lot of serious problems. And the question is, there's a number of drugs, I'll show you in a second, that can block this. These would be very interesting for the population at large to take to increase lifespan. And if you block this is in rats, normal rats, you can see there was a 20% roughly increase with two blockers. One, inoprel is a ACE inhibitor, angiotensin converting enzyme inhibitor, and losartan is the Merck drug that blocks angiotensin receptors. And this is just the data. What you see over here is organ fibrosis in the controls, and in both of these cases, two different ways to block this pathway. Much reduced fibrosis. Here's the blood pressure, 144 in the controls, and reduced to about 100 or so, 110. Okay, and if you look at the fibrosis indexes, it's about 3 or 4 times as much fibrosis. A general pathogenic pathway that can be blocked by a drug or a set of drugs, classes of drugs that are available today. This is Healthspan engineering, probably not considered to be part of SENS. Okay, and I was looking just this morning. I added this here you can see that blocking this has a major effect in autoimmunity. Larry Steinman's group at Stanford has shown that blocking this pathway modulates EAE, I should say, a mirroring model of multiple sclerosis, and probably has a number of effects other than the ones that I've just mentioned with regard to fibrosis. Another very interesting and important problem is medial elastocalcinosis. You're probably not even very aware of this. The solution to this is vitamin K, which modulates gamma carboxylation. It's about 14 proteins that have this double carboxylic acid that chelates calcium. And what's interesting is that here's the control, here's a diet-induced, and here you can see the reduction of calcium in vessels. And basically, vitamin K2 reduced calcium in these models by about 50%. Restored arterial distensibility is a whole talk I could give on this, but again, something that could be very important for that purpose. Okay, what about antioxidants? I mentioned this whole idea of homeostasis. I think Jim Muro will have a few things to say about this a little bit later, but I think there's some problems with inhibiting these. You're probably familiar with this paper that received a huge amount of press. This was published in PNAS about a month ago, and what they found was that this came from Ron Kahn and the group at Harvard, the Joslin Clinic. They're interested in exercise as a way to increase a number of beneficial physiological changes, and what they found was that in exercise individuals, whether they were previously trained or not, vitamin C, vitamin E at a gram a day and 400 units essentially attenuated the improvement in glucose metabolism and the secretion of adiponectin, which is a protective insulin-related hormone. Okay? And so basically these antioxidants somehow block these beneficial things that would reduce disease risk. So, friend or foe, I don't know. The connection here is very complex, and the fact that the Darwinian processes have used this for signaling greatly complicates inhibiting this. Okay, I'd be interested in the stem cell folks talking about this, but apparently ROS are required for example, cardiogenesis, and if you inhibit this, you may inhibit that very important process. And there are a couple of examples of recent mutant mice, and here's a C. elegans where increased oxidative stress actually live longer. So we'll hear more about this in a talk in a few minutes, but these NADPH oxidases are extremely important in making free radicals that block the tyrosine kinases. Okay? This just shows these enzymes and how supplementation with vitamin C blocks them. And all-cause mortality of 230,000 patients, 67 trials, really no benefit. And here we see the prostate cancer, a very large trial, again, almost 300,000 men, and if anything, in this case, multivitamin use increased the rate of advanced prostate cancer. And recently, something that we all thought was related to ROS, autoimmune diseases, are somehow actually protected by this. A group out of Sweden has a whole company now exploiting this. Okay, so maybe we can open up the discussion in terms of small molecular therapy and maybe its contribution to SENS and this whole question of cross-module regulation. So.
Thanks, Jim.
Okay.
Right.